Lesson: Challenges and Future Directions. Artificial intelligence has revolutionized various domains, including cybersecurity. In the realm of vulnerability management, AI presents both opportunities and challenges. Addressing these intricacies requires understanding the current challenges and envisioning future directions for AI-enhanced cybersecurity. AI's role in vulnerability management primarily involves identifying, assessing, and mitigating vulnerabilities in systems. However, deploying AI for these purposes is not without its challenges. One significant challenge is the quality and quantity of data required to train AI models. Effective AI algorithms rely on large datasets to learn and generalize from patterns. In cybersecurity, datasets often need to be expansive and diverse to cover the multitude of potential vulnerabilities. However, acquiring such comprehensive datasets can be difficult due to the sensitive nature of cybersecurity data and the potential for privacy breaches. Moreover, the dynamic nature of cyber threats means that data can quickly become outdated, necessitating continuous updates and retraining of AI models. Another challenge lies in the interpretability of AI models. Many AI systems, particularly those based on deep learning, function as black boxes, making it difficult for cybersecurity professionals to understand the decision-making processes behind their outputs. This lack of transparency can be problematic in a field where accountability and understanding are crucial. For instance, if an AI system flags a particular software as vulnerable, cybersecurity experts need to understand why this determination was made to take appropriate action. AI systems are also susceptible to adversarial attacks. Malicious actors can manipulate inputs to AI models to produce incorrect outputs, thereby compromising the effectiveness of AI in vulnerability management. For example, by subtly altering data fed into an AI system, attackers can create scenarios where vulnerabilities remain undetected or benign components are falsely flagged as threats. This undermines trust in AI systems and highlights the need for robust defenses against such adversarial tactics. The integration of AI into existing cybersecurity frameworks presents additional challenges. Organizations often have established processes and systems for managing vulnerabilities, and integrating AI requires significant changes. These changes involve not only technical adjustments, but also shifts in organizational culture and practices. Resistance to change, combined with the need for substantial investments in AI infrastructure and training, can impede the adoption of AI-enhanced vulnerability management systems. Despite these challenges, the future of AI in vulnerability management holds promise. One promising direction is the development of explainable AI systems. XAI aims to create models that are not only accurate, but also interpretable and transparent. By providing clear explanations for their decisions, XAI systems can enhance trust and enable cybersecurity professionals to better understand and act upon AI-generated insights. This is particularly important in regulated industries where accountability and compliance are critical. Advances in federated learning present another future direction. Federated learning allows AI models to be trained on decentralized data sources without the need to transfer sensitive data to a central location. This approach can mitigate privacy concerns and enable the use of diverse datasets from multiple organizations, enhancing the robustness and generalizability of AI models in vulnerability management. By leveraging federated learning, organizations can collaboratively improve their AI systems while maintaining data privacy. AI's potential to predict and preempt vulnerabilities is also an exciting prospect. Traditional vulnerability management often relies on reactive measures, addressing threats after they have been identified. AI, however, can enable a more proactive approach by predicting potential vulnerabilities based on patterns and trends. For instance, machine learning algorithms can analyze historical data to identify configurations or code segments that are likely to harbor vulnerabilities, allowing organizations to address these areas before they are exploited. This predictive capability can significantly enhance the efficiency and effectiveness of vulnerability management. Furthermore, the integration of AI with other emerging technologies can open new horizons for cybersecurity. For example, Combining AI with blockchain technology can create secure, immutable records of vulnerability assessments and mitigations. Blockchain's decentralized nature can ensure the integrity and transparency of these records, reducing the risk of tampering and enhancing trust among stakeholders. Additionally, the convergence of AI with technologies such as the Internet of Things and 5G can enable more comprehensive and real-time vulnerability management across interconnected devices and networks. Addressing the ethical implications of AI in cybersecurity is another crucial future direction. The use of AI raises ethical concerns, including issues of bias, privacy, and accountability. For instance, AI systems trained on biased data can perpetuate or even exacerbate existing biases, leading to unfair or discriminatory outcomes. Ensuring that AI systems are developed and deployed ethically requires careful consideration of these issues and the implementation of measures to mitigate potential harms. This includes adopting frameworks for ethical AI, conducting regular audits, and involving diverse stakeholders in the development process. In conclusion, while AI presents significant challenges in the context of vulnerability management, it also offers promising future directions. Overcoming challenges related to data quality, interpretability, adversarial attacks, and integration requires concerted efforts from researchers, practitioners, and policymakers. By advancing explainable AI, federated learning, predictive capabilities, and the integration of emerging technologies, the potential of AI to enhance vulnerability management can be realized. Addressing ethical considerations will also be crucial to ensure that AI systems are used responsibly and effectively. As the landscape of cybersecurity continues to evolve, the synergy between AI and vulnerability management will play a pivotal role in safeguarding digital assets and infrastructure.